Knowing the hydronium ion concentration is necessary in for so many reasons. For example, blood has a very narrow range of hydronium ion concentration, and which is required for the person's good health. Uh, these days, I'm growing plants a lot these days during this COVID time, and one thing I learned that for the growth of the plant, it is very important to know whether the soil is acidic or if it is too much acidic, too much basic, or neutral. So, this hydronium ion concentration really helps to learn a lot of things. And so, basically, the concentration of hydronium ion simply means the concentration of the strong acid. If you have a very strong acid, means you have high concentration of hydronium ions. And in the last examples, you saw that when we are putting the hydronium ion concentrations, let's say 4.5 times 10 to the negative fourth, the numbers like these numbers are kind of very complicated to, like, what do they represent. So what we do, we use a pH scale, and that scale is basically used to more conveniently report hydronium ion concentrations. So what is a pH? What is pH? It is a scale that is used to measure the concentration of hydronium ions. The formula is pH equals negative log of hydronium ion concentration, and this pH value will always be between 0 and 14. If the pH is 7, that means the solution is neutral, means the hydronium ion and hydroxide ion concentration is same. pH less than 7, solution is acidic. pH greater than 7, solution is basic. pH less than 7 means you have more hydronium ions than hydroxide ions. pH greater than 7 means you have more hydroxide ions. So let's say if I give you this concentration and I say, tell me whether the solution is acidic or basic, compared to, let's say, if I say pH is 4. Which one is easier to tell? This one, because looking at pH 4, since it is less than 7, that means the solution is acidic. It is hard to tell with these numbers. The lower the pH, the higher is the concentration of hydronium ion, means it's more acidic. More acidic. So if you look at the scale, let's say this is 0, here it is 7, here it is 14. So here is most acidic, and this is most basic and neutral. So if I talk about, let's say, pH 4 versus pH 5, which one is more acidic? pH 4. Lower the pH, higher the concentration of hydronium ions, and that's what decides the acid concentration. Now, a small difference in pH basically relates the larger change in hydronium ion concentration. What does that mean? That means if you have a difference of 1 pH unit, means you have the hydronium ion concentration differing by a factor of 10. This has higher concentration of H3O plus because it has low pH. How much higher? 10 times. Because my relation is with the log. Log means 10 to the power. So a solution with pH 4 has 10 times more hydronium ions compared to pH 5 solution. So if I'm comparing, let's say, pH 2 versus pH 5, which one is more acidic? The solution with pH 2. And how many more hydronium ions present? What's the difference? 5 minus 2 is 3. That means this has 1000 times more hydronium ions compared to solution with pH 5. Now, we're going to do some mathematical problems on this one now. So given the concentration of hydronium ions, this is my formula. Concentration means again what? Molarity. Given the concentration of hydronium ions, you can find the pH. For example, in this question, what is the pH of a urine sample that has hydronium ion concentration of 1 times 10 to the negative fifth? So all I have to do is pH equals to negative log 1 times 10 to the negative fifth. Now, here's the thing, class. If there is number here is 1, only in the case of 1, then your answer is the number written here, which is 5. Why? Because negative log of 10 to the negative fifth, log and 10, they are opposite functions. They cancel out negative, negative, positive. But that you can do it only if it's 1 written here. That's one thing. And another very important thing that you're going to learn about the significant figures in the case of pH. I'm going to change this number. I'm not going to just say 1. I'm going to say 1.0. So now my concentration, if you look at my concentration, how many significant figures are in my concentration? 2. This 0 is significant. There are 2 significant figures. This 0 is significant because there is a decimal in the number. So the rule is, you look at the number of significant figures. Since there are 2, then when you're writing the answer, then you need to have these many number of decimal places. So if I have 2 significant figures, then I need to have 2 decimal places, so my answer should be 5.00. If I just want to keep 1 times 10 to the negative fifth, then I have only 1 significant figure here, then I need to have only 1 digit, 1 decimal place, 1 digit after the decimal. So the number of significant figures in the concentration are equal to the number of decimal places in your pH answer. Let's look at another question. The next question is, what is the pH of a wine if the hydronium ion concentration is 3.2 times 10 to the negative fourth? Now in this one, I cannot just straight away put the answer 4 because this number is not 1. So what I have to do is, I have to go into, look at my calculator, and I'm going to exactly type what is what says in the number. It says, first you type the negative sign, you press log, you put parentheses, you say 3.2, you type it, times 10 to the power negative fourth. 10 to the negative fourth can be done so many. You can do 10 and then you type this and then you say negative fourth and then you find the number. So I have the calculator here. So when I'm typing it, I'm getting, so I'm putting this negative sign here, and then if I'm typing this, I'm getting negative 3.49, negative, negative, positive 3.49. How many decimal places I put? 2 decimal places. Why did I put 2 decimal places? Because how many significant figures I have here? 2. So again, you will see that this is how important this is going to be for the lab you're going to do today, as well as for your final exam. So 2 significant figures, so that means when I'm writing my pH value, I need to have 2 decimal places. Let's do the opposite. We know that, for example, if we have an equation with 2 variables, as long as I know the value of one, I should be able to find the other one. What does that mean? So if I have my pH equals negative log of hydronium ion concentration, then uh, if hydronium ion concentration is given, I should be able to find pH like we saw in these two examples. Or if pH is given, you should be able to find hydronium ion concentration. And how you do that? You do hydronium ion concentration is 10 to the negative pH. So what is the hydronium ion concentration in lemon juice? That has a pH of about 2.0. So my hydronium ion concentration will be equal to 10 to the power negative 2.0. And if I will do this 10 to the power negative 2.0, then let's see what I get. All I'm doing, I'm just putting 10 to the power negative 2.0, and I'm getting 0.01. So let's put 0.01 first, whatever is showing in the calculator, and then we can decide about the significant figures. So now we are going opposite. So what is the rule for that? Now you have to notice the number of decimals given in the pH. How many decimals are given? Decimal places? 1 decimal place. So then your final answer, so now we are doing the opposite, then your final answer should have only one significant figure. So think about it. Here we looked at how many significant figures are here, and then we put that many number of decimal places. In this case, we are going to look at, since we are doing it opposite now, we are going to look at the decimal places, and then we're going to have that many number of significant figures. So 2.0 has two significant figures. I'm sorry. 2.0 has one decimal place. So that means my final answer needs to have only one significant figure. So 0.01 has only one significant figure. One more time, if the pH is given and you have to find the hydronium ion concentration, you look at the number of decimal places. Number of decimal places is 1, and that means your answer should have one significant figure. It's a lot of information that I'm giving you within an hour or so, but then keep in mind that's what the learning is. You forget things, and then you have to keep watching these videos again and again, write your own notes, and go from there. So now this is not really a question, but what if you have to find OH negative concentration if you are given pH? Because pH is related to hydronium ion concentration. So what we can do, on the last slide, we learned this formula, Kw equals H3O plus times OH negative, and we know Kw is constant. Using this formula, and here, and we are given OH negative concentration, I will put that OH negative concentration value here and calculate H3O plus. Once I have H3O plus, then I can use the formula pH equals to negative log of H3O plus to find the pH. So this, if I have a question like this, then it is going to be two-step. First find H3O plus, then plug it to get the pH value.